Okay, we're starting section 3.5 now. So this is equations of lines. So we've seen standard form, we've seen slope-intercept, and this is introducing the third and final form of the line. So we have 4 objectives to get through in this section. The first is to be able to use our new form, which is called point-slope form. Of a line. The second is revisiting equations of vertical and horizontal lines. Mainly in the context of point-slope form. Our third objective is looking at more equations of parallel and perpendicular lines. And our final objective is problem solving. Which of course is our book's way of saying word problems, as we well know. So, point slope form of a line. This is, as I said, the third form of a line, known as point slope. This requires either 2 points that are on the line or 1 point and the slope of the line. So if m is the slope of a line that passes through the point a comma b, then the equation of that line will be y minus b equals m times x minus a. And then this can be simplified, of course, distributing m and moving the b over to get our slope-intercept form. So this is probably the most well-used and well-known form of the line after slope-intercept form, and that's only because you need the minimum number of things. So slope-intercept form, you have to have specifically the intercept, whereas here you just need any old point. If it's the intercept, then great. If not, then it's not a big deal, and you can do it without knowing the slope as long as you have 2 lines. So we're going to walk through a couple examples here. This first one, write an equation on a line whose slope is -3 and goes through the point 1, -5. So this is a straight application of the equation. So this is our b and this is our a for our formula. So we have y minus a -5 equals -3 is our slope, x minus 1. And this is y plus 5 equals -3 times x minus 1. Now for the most part this is good enough. This is an equation of the line. What you want to be aware of in your homework and on a quiz or a test, see what form they want the line is. They may say fully reduce it or write it in slope-intercept form. So y equals mx plus b, and if we did that, that would be y equals -3x. This would be plus 3 and then minus 5. So that would be minus 2. So these are equivalent forms, and you just have to see what version of the line the problem is asking for. So now in this next example, it's a little bit different. It says find the equation of the line that goes through these 2 points. So now we need to first construct the slope by doing our y2 minus y1 over x2 minus x1. So that's going to be 5 minus 0 over -4 minus 4. So we get -5 over 8 is our slope. And then you can pick either point. I typically pick a point that has a 0 in it because it's easier, a 0 or a 1 or something of that nature, just small numbers. And so then we have y minus 0 equals -5/8 times x minus 4, or y equals -5/8 x, and then minus 4 times a -5/8 is plus 5 over 2, because we can cancel this 4 and this 8 to make it 5 over 2. And again, these are equivalent forms of the equation. It's just about simplifying or not simplifying depending on what your problem is asking of you. So I've got 2 practice problems here for you to try doing the exact same thing. only you're given 2 points for both of these, so you can work out the slopes and then check your work. So we're going to continue on with a few more examples here. Write the equation of a line through the point 2, 2 that has undefined slope. So remember, undefined slope, this tells us that we are vertical. And that means that we are x equals something. And if it goes through 2, 2, that means we have to have x equals 2. And that would be our answer. In the next problem, we have a defined slope, it's 0. So we could use slope-intercept or point-slope form, y minus 2 equals 0 times x minus 2. But 0 times anything is 0. So this just becomes y minus 2 equals 0. Or y equals 2. So if you forget that horizontal lines have slope of 0, using point-slope form, you will get the right answer. You just have to make sure that you're identifying those. If you notice this first, like we did here, then you can immediately jump to the answer y equals 2, because it has to go through that point 2, 2 as well. Okay, 2 more examples, very similar. Vertical and horizontal lines. I'll let you figure out which is which. In the next example on this page, we're going to be doing some more parallel and perpendicular lines. So we're going to find a parallel and a perpendicular line to 3x plus 4y equals negative 12. The parallel line goes through 1, 1. The perpendicular line goes through negative 3, negative 6. So remember, in both cases, for the parallel and perpendicular lines, we need the slope. The slope being, in standard form, negative a over b, or negative 3 over 4. Could solve for y to get that as well. And so for our parallel line, it's got to go through this point. The slope needs to be this exactly to be parallel. So we have y minus 1 equals negative 3 over 4 times x minus 1. And again, this is a fully realized equation of a line, but let's say it asks us to put it in slope-intercept. So this would be y minus 1 equals negative 3/4 x plus 3/4. 1 is 4 over 4, so when I add that over, I can collect like terms easily. And we have y equals negative 3/4 times x plus 7 over 4. And that's our parallel line that goes through 1, 1. And you could double check, plug in 1. Negative 3/4 times 1 is negative 3/4, plus 7/4 is 4/4, so that'll give us 1, 1, which is what we want. And then for our perpendicular line that we need to find, the slope needs to be the opposite reciprocal of this slope, so that's going to be positive 4 over 3. And so then our point now is negative 3, negative 6 for this line, so we have y minus a negative 6 equals 4 over 3 times x minus a negative 3. Negative minus negative makes positive, so we have y plus 6 equals 4 over 3x plus 4 minus our 6 over. We have y equals 4/3 x minus 2. Those are our 2 parallel and perpendicular lines through the given points. So this is just more practice using point-slope form, more practice finding a parallel and a perpendicular line. And there's a practice problem for you to try as well, doing the same thing. A parallel line through a given point, perpendicular line through a given point. You can try that out. Here we have a little example of a word problem. Southern Star Realty is a real estate company that has seen growth in sales since 2010. In 2012, the company sold 200 houses, and in 2017, the company sold 275 houses. We want to predict the number of houses this company will sell in 2026. So with this type of problem, there's an added wrinkle of, we know that this needs to be a line because we're in the line section, but we also need to have a way to represent years better than the number. Because if we do 2000s, it's going to be a really big number. So typically what happens is we say, let x be years after, I forgot the T, 2010. So then if x equals 2, this is the year 2012. And this is a common way to do this. And then we can construct some paired data. So 2012 is 2, they sold 200 houses. 2017 is 7 years after 2010, and they sold 275. So now we have 2 points, and anytime you see the word predict or model, that means you need to set up an equation or a function. And since we're talking about linear equations in this chapter, that means we're going to be talking about a linear equation here. So I'm going to find a slope with these 2 points. So 275 minus 200 for y2 minus y1, and then 7 minus 2 for x2 minus x1. So this gives me 75 over 5, and that does go evenly 15 times. And then just like the last problem we did, you just pick one of your points. Since we're given 2, doesn't matter which one. I'm going to pick this one because 200 seems like a little bit easier number to work with than 275. And so we have y minus 200 equals, our slope is 15, x minus 2. And simplifying, that would be y equals 15x minus 30 plus 200. Moving that 200 over and distributing the 15. And so we get y equals 15x plus 170. So this is our model. Now we can predict what happens in 2026. So y equals 15 times 26 plus 170. And I'm just going to punch that into my calculator, and that tells me we have 560, and this is houses sold in 2026 is our final answer. So there's another problem here for you to try out on your own. Notice the word constant. This is another way to figure out that you're doing linear equations. Just like up here we had predict. Also, again, we're in the linear chapter, so it makes sense that it would be linear. But I believe that's the end. So next video will be our last section of chapter 3.